I'm particularly happy to introduce Kishio to you today, Kishio-san. He is the manager of the Chemical Products R&D Division at Konica Minolta. He is the winner of the Robust Quality Engineering Award 9 times. And holds a number of those prizes and a number of patents. He's working with Professor Martin Fisher on a project that's part of the Media X initiative on measuring and improving the productivity of people who work with information. And that's a very interesting project that they're working on. His experience in using the Taguchi Method for technology innovation. It's a method that is not as well known in the United States as it is in Japan and in Russia too, I believe. So it's a great privilege and a pleasure to introduce Kishio today and to invite him to share some perspectives on the Taguchi Method and how it can be used for technology innovation. He has some experiences and he's going to talk from his experiences. So welcome.
Thank you all for introducing me, Mata. Thank you for coming here all. Today's talk is, of course, about Taguchi Method. I'll talk for about 40 or 45 minutes maybe. But if you have any questions or if you have any comments for my talk, please interrupt me anytime.
I'm going to be the first one to interrupt you. I accept your invitation. Yes. You would click this on. We are recording this presentation, so this will give a better picture.
Okay. That's clear. Okay, so please interrupt me if you have any questions or any comments. Sometimes I might be too technical, so when that you stopped me, it's your task today. Okay, so before going talk, I introduced about my company, Konica Minolta. I believe it's helpful you to understand today's my talk. Our business domain is very widely now. Konica Minolta is, of course, the manufacturer, and we have many business domains. Yeah, about their printers, multifunction copiers, and second column, their production printing systems. And third, their optical products like optical film, optical pickup lenses, and some optical disc devices. The fourth, there are medical and healthcare products. Many diagnosis system for human body. And next, there are many sensoring systems for colors or for shapers. We have 3D scanners too. And there are inkjet printing systems. We have big inkjet printers for textile. or for big advertisement posters. And of course, we are manufacturing inkjet inks. On the bottom, this is a planetarium. We have a big share in the planetarium fields. This is my profile. As Masa said, I'm a chemical product engineer and a manager, also manager for R&D divisions. And today's main topics are expert in Taguchi method and robust quality engineering. My interest, as I said, I'm an engineer and also I'm a manager. So now I'm really concerned to maximize engineers' performances and to encourage engineers' creativity. And third, to get high productivity in working place. Working place, that means especially R&D fields or design fields. And of course, these are strongly related to Taguchi method. Okay, so let's get started today's main talk about Taguchi method. I ready 3 items for talk. First, what is Taguchi method? Second, my experiences in Taguchi method. And the last, Taguchi method really induces technology innovations. I'd like to discuss with you about technology innovations, mainly. Okay, so the first, what is Taguchi method? You might know a common design of experiments, but Taguchi method is really different from them. He is Dr. Taguchi. He developed this efficient method for designing. It's a really unique methodology for efficiently optimizing designs. Yeah. Taguchi method is mainly focused on robust design. It's a kind of technical term, but very important term for understanding Taguchi method and Taguchi method's concept. At first, the word robust, that means not just strong and tough, but also flexible, reliable, and efficient. In common, the robust has the word robust has the image really massive and strong, like a tank or wrestlers. But in Taguchi method, the robust is not only strong, flexible, and that's a really important part. And second, robust design. Robust design means to develop robust products and or robust processes. And robust products and or robust processes are minimally impacted by external factors such as environmental, for example, temperatures, humidities, sunlight, some kind of physical stresses, or such as client use or manufacturing conditions. So tough user is really hardly the product, or in the factory or in the plant, there are really unstable situation or condition, but we can got good qualities and good performances of products or processes. So, this is a really important concept or strategy in Taguchi method. We said design strategies for high performance and robustness. In many cases, performance and robustness is conflict, but Taguchi method can get both. This is a design in initial, and that is the target optimized design. Commonly, we try to get optimized design directory, but it's a really long journey. Sometimes we lost the way. Sometimes we give up to reach the goal and change plans. For this situation, Taguchi method takes really unique strategy. This is Taguchi method strategy. We call it two-step optimizing strategy. 2 steps. At first, we get robustness. That means improve SN ratio. I'll explain about SN ratio later. But you can have the image. This is initial design. If we got robustness, the arrow is focusing in one area, but not
a center. The first step, it's okay. We think Taguchi method, think just robustness. We focus on only robustness. And second step, adjust to target. Already we got robustness, so to make adjustment is really easy in actual. And this is orthogonal array. You might know the orthogonal array for design of experiments. It's common, but in Taguchi method, we use mainly L18 array. L18 array is really special in orthogonal arrays. We have many sizes and many kinds of orthogonal array, but L18 array is really recommended in Taguchi method. And this is a step of an experiment. And I underlined some special technical terms. Such words and such terms are never used in other DOE, other design of experiments. The terms are the unique in Taguchi method. But I'm really sorry. I have not enough time for steps in for explain in detail. So today you just feel the atmosphere of Taguchi method. If you'd like to know in detail, please let me know. I'm really delightful to your offer. But some words I'd like to explain. The word SN ratio. The SN ratio is a measure of robustness. The higher is better. You know, SN ratio, the word SN ratio is in signal field or some sound field. But Dr. Taguchi expands the word meaning for design field. Okay, so I'll show you a table of experiments. This is experiment plan. Here is L18 array. orthogonal L18 array, we lay out the control factors. That means design parameters or design factors into the orthogonal array. L18 array has 8 columns. So we can experiment 8 factors at the same time. And the array shows the 18 combinations for parameters. That means we have to do 18 experiments. You might thought that's too big. We need much time. Actually, no. You don't need much time because for these experiments we use prototypes, or we use test pieces, or we use test tubes. So it's a really small experiment. Later I show you the practical case in our company, so you can see the experiment is needed long time. Okay, and we fill in the experimental data and analyze to SN ratio and responses. As I said, the first step we focus on SN ratio, and second step we adjust response to target. After we got 18 SN ratio, we can make this graph, control factorial effect. Vertical axis SN ratio. Higher is better. And horizontal axis control factors. And these are initial parameters of design. And we can find really easily to optimize combination of parameters. The red circle, we choose the higher SN ratio of factors. This graph shows the combination of red circle parameters is higher robustness. And Taguchi method has a self-check step for results of experiments. We can confirm the result is how reliable or how trustable That means the estimated result and practical result is at the same or differ. This is the check steps, and we check the gain at first. This is estimated gain. Gain means the measure of improvement. And this is confirmed gain. Estimated gain is from factorial effect graph, and confirmed gain is from in practice. Compare the gains. That means reliable results. Similar is better, of course. I'd like to show some cases in our company, but before that, I introduce you robust quality engineering. Now, Taguchi method is advanced to robust quality engineering. It includes many technologies for engineering design. Here is the Taguchi method. Today I show you. And there are many technologies. And now in Japan, many engineers focuses on this technology, MT system. MT system is a really unique technology for pattern recognition or diagnosis or decision making. And this is a book I wrote about MT system. It's a kind of guidance for using MT system. You can buy this book at Amazon.com, but I'm sorry, this book is written in Japanese only. Yeah. Okay, so I'll show you some cases in Taguchi methods. I read 3 cases today. First, inkjet printer for wide format printing. Second, optical film for flat panel display. Flat panel TV or flat panel display for computers. And third, chemical toner for Electro-Photo printing. The second floor in this hall, there are Konica Minolta production printing systems. Please you might know, but if you don't, please go upstairs and look at big printers. Okay. Yeah. But today I have not enough time for explain in detail so I'll show you essences of these cases today. If you are interested in these cases, I can show you in detail later, so please let me know. But first case, inkjet printer for wide format papers. That's just an image. In this case, we design more bigger printing systems with inkjet. What's the problem? Printer users want to print with various papers, really thick papers, thin papers, or rough papers, really flexible papers. But quality of paper feed depends on, of course, characters of papers. In this situation, we engineers have three alternatives. First, these papers user can use for these printers. So that means you should use this paper only. Of course, user doesn't like such printer. Second alternative, switch paper feed conditions according to print papers. So thick paper, when user uses, switch the mode of the printer. Thin paper, switch the mode. It can provide the printers for using a wide range of papers, but really complex for users. So we choose third alternatives. Get robustness for any papers. That means one more printers can feed papers only one more. So please check this area. We use L18 array, and 2 times we do experiments. It takes only 2 days. 2 days only. And as a result, we got really optimized condition of printers. All paper can be fed and passed accurately without switching mode. That's a very good result, we think. Okay, the second case is for optical film. Actually, this case is too technical, so I don't like to explain in detail, just a sense. Get high qualities of wide view angle resolution films. That's a technical word. But we engineers are concerned with qualities and cost trade-off. So we have three alternatives. Picking films, that means high cost. Give up, get robustness. Of course, we choose third alternative. We take 2 weeks for optimized film design. Only 2 weeks. And as a result, we got the film with higher quality and lower cost than all competitors. At that time, we got number 1 products in 2 weeks. And the third case, chemical toner. This is the main field for me, chemical products designing. The problem, develop completely new toner by chemical synthesis process and build new plant for manufacturing chemical toner. Launch new printer with chemical toner in 1 year. Ooh, that's a big project. We choose 3 alternatives. Negotiate to extend due date. Oh, sorry, it's difficult. We cannot achieve in 1 year. Second, give up for this. Third, get robustness. Actually, we do many experiments using L18, of course in Taguchi Method. So we took a half year or more, but as a result, we got achieved all targets with no delay. And we got a new and unique technologies for toners. And that's a kind of technical. This is our chemical toner. Really a good shape. Okay. The third items about innovations. 2 types of engineers' behaviors in private companies. 1, fear failures extreme. That means better safe than sorry. Second type, fall in love and stuck with own idea. My idea always the best. But they can hardly create technology innovations. There might be in Japan only, I don't know. Please give me your opinion. Engineers will fear failures because they are required to meet a severe criteria: security, quality, cost, delivery. So they tend to be conservative unconsciously. They rely on their previous successful case, and presidential and traditional way is persuasive. And the second type, engineers who fall in love and stuck with one idea to the end. Engineers never give up their own idea, even if they find black spot on it, because they are too self-conscious. Finally, they get crushed. Then they find wasting time, wasting money. How does Taguchi method work in these situations? First, Taguchi method tells engineers the possibility of their ideas quickly and surely. Second, engineers can give up early stage with confidence. And third, engineers try to find out next innovative ideas desperately. We say it, the cornered rat will bite the cats. Okay, today's summary. What is Taguchi method? It's an efficient methodology for robust design. We can get designs optimized quickly and reliably. And second, my experiences in Taguchi method, I provide just three cases from my extensive experiences. They show the high potential of Taguchi method. The third, Taguchi method induces technology innovation. Actually, the main target of Taguchi method is to innovate technologies, not only optimize action, but innovate technologies. Okay, that's all today's talk of me. So please give me questions or comments. I'd like to discuss with you all. Thank you.
Thank you very much. We'll have some time, and if you don't mind, we could ask you some questions about the many other experiences
Oh, yeah,
other
okay.
than those three that you have had. And one question that's on my mind,
Oh, yeah.
if I can go first while others are thinking, it seems that this method would be very well suited to improving designs of products that already exist. In your experience, has it been used to also create robustness in things that are really quite novel,
Oh, yeah.
quite new? Can it be used that way? Is the tolerance of the L18 and the noise factors, can that accommodate big changes?
Actually, yes.
Can you tell us about one of those experiences?
Yeah. You mean the style way of experiments?
Yes, where the innovation has been drastically different, dramatically different from what's happened before.
Yeah. Actually, the third case, about chemical toner, in common, it takes 3 or 5 years for development of toners, but now we can develop only one or lesser. So, because we aggressively changed the design process, and I can respond with you. Now, the optimized action is only small part for designers. For designers, we have to do more new challenges, more new technologies, research. So we have to use the time for optimizing shorter. That's really important, I think. Can I answer? Yeah.
So do you use this method for every innovation or 10% of the innovations?
Actually, not all, but many main stages we use.
So is there resistance from other engineers about using these methods?
Really good questions. Yeah. Actually, there are some resistance in our companies now, but in these 10 years, we changed generations. So new engineers don't have such resist feeling. Yeah, please.
Can you make mistakes in identifying the control factors? Is it hard to find the proper control factors?
Yeah. Before we getting used to the way in Taguchi method, it's really a tough program for engineers. But Now, we have many experiences, we have many cases. We learned from them. So actually, I can work on many fields, not only printers or not only toners, but in the mechanical fields, in the electronics fields. That's really in experiments fields, but the experiments is really useful for find and to define factors or parameters.
Is there a way for the experience of the user, the anticipated user or the real user, to be considered in the Taguchi method?
Real users.
The users, yes. Where in the, whether it's the toner and what a person's experience is in inserting the toner, or if it is in the flat panel display and it's the movement of the user in the room, or just whatever the user's experience is, does that become one of the control factors, one of the noise factors, or how does the user's experience
Yeah.
included?
User of products, you mean?
Yes.
User get more durable products and stable products. That means in summer or in winter, the product shows same performance. In old days, the engines of a car, in summer it's easy to start, but in winter we need more time. It's an old story. But if the engine of a car has robustness in summer, in winter, that's no problem. User can got quick start. Any season, any days, a new car, old car, no problem. That's the robustness. So the robustness gives all users their media good merit, and of course we can provide users with lower costs.
Kishio-san, you're teaching this method to many people. Who are the people who learn this best? Are they new engineers, or are they in the company, in your company? Are students in Japan, engineering students, learning this method in school? Where is it taught?
Yeah, actually not yet in school. So I meet engineers in companies, in our company and out of our companies. Now, many companies call me to help in use Taguchi method. And my company, Konica Minolta, actually, they said it's okay to get experiments. Is useful for our Konica Minolta company too. So that's really good situations of me, and of course of Konica Minolta.
Well, I want to thank you for bringing the Taguchi Method to the Access Stanford University. Thank you very much.
Thank you very much.